Okay, the notes for today are on exponentials, okay? And so here's the basic form of an exponential. It's f of x equals a b to the x power, okay? The main thing to notice is that there's a variable in the exponent, okay? All right, variable in the exponent. So here's a couple examples of what an exponential function will look like, okay? F of x equals 3 parentheses 1/2 to the x power. Maybe f of x equals 1/2 times -2 to the x power, okay? Excuse me, that is wrong. That should be +2. Okay, the negative would be on the 1/2 in front, okay? And then g of x equals, let's say 0.7 times 6 to the x power. Those are all examples of exponential functions, okay? Here's what we're going to be doing with them. Number one is just evaluating them. This is easy. You're going to use your calculator to evaluate functions. Let's read the problem. It says the function f of x equals 2 parentheses 3 to the x power models an insect population after x days, okay? So this is what the exponent represents, the number of days. What will the population be on the 5th day, okay? What will it be on the 5th day? Okay, so to answer this question, we're going to look at the answer to it, okay? You're basically just plugging in 5, going to plug in 5 for both x's, anywhere that there's an x, okay? But when you do this on your calculator, you're going to use this key, okay? Remember, it's a caret top, okay? You're going to press 3 caret top 5, okay? And get that answer, and then you multiply by 2 to finish the problem, okay? So this is the first step, second step, third step, which is the answer, okay? So 486 insects on the 5th day, all right? And then the second one, pause these anytime so you can do the problems yourself and see what you would get, okay? That's the best way to practice, okay? And then here we have, okay, the function 1500 times 0.995 to the x power, where x is the time in years, models a prairie dog population. How many prairie dogs will there be in 8 years, okay? So here's the answer. We're going to substitute 8. We're going to substitute 8 for x, both places, all right? When you work that out, it's going to equal about 1,441 prairie dogs after 8 years, okay? This is the number of years, okay? All right, that's the first thing, that's evaluating. Next thing we're going to do is identify whether something's an exponential function. So these examples say, tell whether each set of ordered pairs satisfies an exponential function, and then explain your answer. So we did the same thing, if you remember, we did the same thing with linear, okay? Now we're going to talk about it with exponentials, okay? What does it mean when it's an exponential, okay? So when it's an exponential, it's going to grow by a common ratio, okay? You will find a common ratio, okay? If you find a common ratio, then we know that it's exponential, okay? Find a common ratio, then it's exponential, okay? All right, and then, so let's look at the answer to these two problems. So this is just the two problems listed out in a table format. And if you look at this first problem, these are going up by 1 on the left-hand side, and then these are going up by 2 on the right-hand side. So we know this is an exponential function, okay, because it has a common ratio. If you remember right, the common ratio also meant that it was a geometric sequence, okay? Geometric sequence, okay? If you look on the right, you can see that this is not going up by a common ratio. It's not going up by a consistent or multiplied by the same thing every time, so we say it's not an exponential function, okay? An important note here is that linear functions, from a few weeks ago, linear means the same thing as arithmetic, right? arithmetic. Oh, I spelled it, excuse me, arithmetic, and that exponential means the same thing as geometric, okay? Okay, that's real important facts to memorize. And then you remember that this top one, arithmetic, had a common difference. And then this one, geometric, had a common ratio. Okay? All right, next example, or next one we're going to do is graph an exponential. Okay, so we're going to graph this. The first thing we're going to look at when we graph it is basically just choosing several values of x and generating order pairs. So we're choosing these numbers. We choose -1 to +2. Okay, you can choose whatever you want, but normally we choose these because they're easy numbers to use. Okay, easy numbers to use. We plug them in for x, and then we get out these numbers and create this table. Okay, we generated or created this table. Okay, once we get that, you can have some points to graph, and that's where this comes from. It says graph the order pairs. We just graph what was over here. Okay, we just take all these values and graph them over here. And again, notice that you're going to get an exponential curve. So it will look something like this every time, going up, going down, all right, in some kind of way. Okay, and then here's the last page, or one of the last pages. Graph -5, 2 to the x value. Again, we're going to choose these values. Okay, we choose those. These would always be good numbers to choose. You can choose -1, 0, 1, and 2 every time. That works. And then we're going to get these out. Okay, and then we're going to graph these order pairs. Okay, so over here to the right is what it looks like to graph those order pairs. And notice that this one would represent a decay or going down. Okay, and then the last slide, if you can answer this, if you can read this and answer this riddle, I'll give you some bonus points in class. Okay, so if you can read it, answer it, that'd be awesome. If not, just take the notes.